Hi, 8M6, lesson 5, increasing and decreasing functions. We talked about this in lesson 4. We're going to continue it a little bit in lesson 5 here, and we're going to work some examples, some homework help, see what the difference is. We've been doing a lot of constant functions, right? Constant functions, constantly increasing or constantly decreasing functions. But today we're going to talk about ones that increase and decrease at variable rates as well. Let's see what we're talking about. Okay, head on over here to our sketch pad. Okay, so we're going to be talking again about increasing and decreasing functions, but ones that do so at variable rates and constant rates. So let's look at two examples here, and we'll draw one in orange and we'll draw one in green, and we'll see what we're talking about. So here we're talking about the example of savings. So let's just say in orange we have, this will be Andrew. Andrew is saving $10 every day, and he starts at 0. So he starts at 0, and we know how to graph this, right? Now let's see, what's he doing? Yeah, he's 10 a day. So I actually wrote the wrong number here. So let's just get rid of this thing here, and let's get this right from the get-go. If he saves $10 a day after one day he has $10, and after 2 days he has $20, and after 3 days he has $30, and realize that every day he adds 10, right? That's our delta y. Our delta y is plus 10. And so that we know this is going to be our slope. We know that it's going to be linear. We know that it's because we know that it's constant rate. So let's look at this. So 0, 0, 1, 10, 2, 20, 3, 30, 4, 40, 5. See, we know that this is a straight line. This is everything we've been learning for a long time. We have a nice straight line. It is ever increasing at a constant rate. So, and the slope is, a constant m of 10. And the units, again, of our slope are dollars, our y units divided by our x unit. So it's $10 per day. Everything is just holding together really nicely, just as we've learned from day 1, or really lesson 4. Or unit 4. Now let's look here at, who is this? This is B. We need a B name. Okay, how about Betty? Betty saves at a variable rate. The first day she saves 5. So this is going to be plus 5 on day 1. But on day 2 she adds $10. So now she's up to 15. And on day 3 she adds 15. So now she's up to 30. So we can see that she's saving at a rate that's not constant. And we can see that because we add 5 and 10 and 15. So let's graph that and see what this looks like. Because if we can see what a variable rate, a non-constant slope looks like, then we can begin to recognize it as we look at other examples. So after we got 0, 0, we have same starting place, but after 1 day we only have $5. And after 2 days we have $15. After 3 days we have $30. But after 4 days now we have $50. Now we have more. And after 5 days we have, this should be a 5. After 5 days we have $75. So let's graph this guy. I'm just going to do it by freehand here. And what do we notice? We notice that one, let's make some observations here. One, in the green line, these are all green observations. It is not a straight line. That's the first thing. 2, let's look at the slopes. This is a slope. What's happening to the slope of this line as we continue from left to right? And for those of you who see that, is this one, which one's steeper? That's the question. Let's look at, the question mark is steepness. I'm asking you a question, which is, what happens to the steepness as we go left to right? Well, for those of you who observe that this is not that steep, just think of a mountain. This is not that steep. This is steeper. This is steeper. It gets steeper. Okay. So let's see if we can tie together these concepts. First, of not a straight line and it getting steeper with what we know to be true, and then make some generalizations. So first of all, it's not a straight line, so this is not linear. It is not linear. Which also means that the slope is not constant. Right? The slope isn't constant. If the slope was constant, we'd have a flat line, but here's the slope is here, now it gets steeper, now it gets steeper. We know that it is changing. So it is getting steeper and steeper, and because it's getting steeper, we're increasing faster and faster. Right? So see, we save $5 on the first day, 10 on the second day. So this is increasing. So because we have an increasing number, we have an increasing slope. It gets steeper. So that's kind of the idea. We have constant rates and we have non-constant rates. And for non-constant rates, we have to identify whether we're getting steeper or not as steep. And then we can make some determinations about what's going on. This is very important in your reading graphs, and especially when you're reading graphs and trying to understand what's going on in the real world. So let's go forward and keep those things in mind. Now, here's an example of we're walking for charity. Okay, so these are from your book. These 4 examples of linear functions and nonlinear functions are from your book. And now I'm going to just say that over here we have miles. In all cases, this is the number of miles that we walk. Well, let's look at that. Let's just look at the top 2 this way. We're going to look at this top 2 in terms of miles walking for charity. And on the bottom, we're going to look at it as draining a tub. So this is going to be gallons, and this is going to be minutes. Gallons, minutes. Okay, so we'll focus on that one in a second. Okay, so over here, I know that what am I doing? If these are miles that I'm walking, whoops, and these are in hours, what is going on? What are our units? First of all, what are our units? Our slope units. Well, our slope units are our y over our x, our y units over our x units. So when we talk about the slope, we're talking about miles per hour. Okay, so if we have, in this first example, our slope is constant. So here we have a constant rate or a constant slope. So we have a constant, what is miles per hour? That's a speed. So we have a constant speed. And it turns out that if we go, if this is 10, 10, because we've gone in 10 hours, we've gone 10 miles. and down here we got 0, 0. We can calculate our slope, which is 10 minus 0 over 10 minus 0 equals 10 over 10, which is equal to 1. So we're going 1 mile per hour. So we're walking for charity at a rate of 1 mile per hour. So that's this left example. Now here we know that you're not going at a constant rate, because if you were going at a constant rate, you'd have a straight line. So what can we presume? So what we're going to do over here is we're going to identify rates at different parts of the graph. And that's going to help us identify what is going on. Some of you might be able to see it right away, but let's just take apart and let's look at the first. Let's just say we have the first part of the graph. That'll be this. We have the second part of the graph. Let's say that that's this. And then the third part of the graph will be this. And I'll make the second part of the graph, we'll just make that purple so we can kind of differentiate. 3 different parts of the graph. So here we have a point, and this point here is 3, 1. This point here is about 8, 6. And here we have a point of 10, 10. All right, this is about 8, 6. So let's look at what's going on with our slope at each point, at each section. So over here, we're going to estimate it by just pretending it's like almost a straight line and just seeing what our average slope is here. So it's going to be 1 minus, and this is 0, 0. So we go 1 minus 0, our change in y, over 3 minus 0. That's our change in x. So here we have 1/3. So that's our slope for the first part. Now our slope for the second part is going to be 6 minus 1 over 8 minus 3. So 6 minus 1 over 8 minus 3. So that's 5 over 5. So here our slope is 1. Our average slope in here is about 1. It's not constant 1, but it's about 1 it's 1 on average. And now let's look at the last part. The last part is 10 minus 6 over 10 minus 8. So that's 4 over 2. So that's 2. So our slope is going from, let's just write that here. It goes from 0.33, that's 1/3, to 1.0 to 2.0. So it is increasing. The slope is increasing. So we are walking slow, medium, and fast. So we're getting faster as we walk, and that makes sense. Why does it make sense? Because in this first 3 hours, we only walked 1 mile, so that's pretty slow. Then we walked 5 miles in 5 hours, that's a little faster, and then we walked 4 miles in just 2 hours. So you can see that the steeper the curve gets, the faster we're walking. This all makes sense from a verbal model, and from a graphical model, and from an algebraic model. Our M is increasing, our slope is increasing visually, and our story, our person is increasing, walking faster. So this all makes a lot of sense. Now let's look down here at the bathtub example. In the bathtub example, we are draining, well, let's see, this is 0, 10. So we start with a bathtub with 10 gallons of water. At minute 0, we have 10 gallons. And at minute 10, we have 0 gallons. So our slope is 0 minus 10, our change in y, over our change in x, 10 minus 0, which is equal to negative 10 over 10, which is equal to negative 1. Why is it negative? It's because we're decreasing. We learned that in the last lesson, that negative means decreasing. So we're negative 1, and what are our units? Gallons per minute. And it's constant. It's a constant. 1 gallon per minute. After 1 minute, we've lost 1 gallon. After 2, we've lost 2. After 3, we've gone down to 3, which is 7 left. After 5, we've gone down to 5 gallons. So after 5 minutes, we've lost 5 gallons. So it's a constant 1 gallon per minute. And that makes sense. Now let's look over here at this example. Here we have 13 gallons to start our tubs. And I'm a little upset that this 1, 2, 3, 4. Yeah, this is not this. They didn't start with 10, but it's 13, and we can just look at the shape of the curve. And after 8, we're at 0. We have 8 comma 0. Now what we're going to do, because this is not a constant function, we're going to look at what's going on 3 different sections of the curve. And so let's do that right here. Let's make these our examples. So right here, this is 0 comma 13. This here is 2 comma 12. This over here is, let's just do this one. Let's forget about that point. Let's do this point. This is 6 comma 7. So let's look at this section, and then this section. And I think what you're going to see is that this isn't so steep. This is steeper, and this is the most steep. And so we'll understand in a decreasing function what that means. And let's just be really clear here. Let's just get rid of this guy so we can see things easier. We'll do this in orange for fun. Okay, so here, what's our slope here? Well, it's 12 minus 13 over 2 minus 0. So that's equal to negative 1 over 2. So that's negative a half. That's our slope right here. Now our slope in the second section is 7 minus 12 over 6 minus 2. Well, that's equal to negative 5 over 4. So that's equal to negative 1.25. So this is also equal to negative 0.5, that first piece. We'll do it all in decimal. And then on the third part, we have, well, 0 minus 7 over 8 minus 6. That's equal to negative 7 over 2. So that's negative 3.5. Okay, so here, this is, and what are our units? Our units are gallons per minute. So here, in the first part, we're losing a half a gallon per minute. Then we move to taking out about an average of negative 1.25 gallons per minute. So this is draining faster, drains faster. And then we lose 3.5 gallons per minute at the end. So this is drains fastest. So the bigger the negative, the faster we drain, the faster we decrease. So here, again, not very shallow, or not very decreasing very fast. On average here, we're decreasing faster. Then over here, we're decreasing fastest. So because it's steeper, we drain faster. So that's the rule. If we're increasing faster, if the slope gets bigger, and we're decreasing faster if the slope gets bigger in a negative fashion. So that's what we're going to look at as we move forward. Let's lay down some happy cats, because this is some pretty good learning here. Very important concepts. How to read graphs that are flat, or have straight lines and how to read the graphs that have curved lines. Okay, let's move forward. Now what we're going to do is we're going to do this thing differently. I'm going to ask you to sketch a graph of a bathtub that fills. So it's filling, it's increasing at a constant rate. So we start at 0. Now, what I want you to do, this is homework help, so I want you to pause and try this, and if you can't do that, you can watch me do it. But again, as I always tell you, you're going to learn more if you try it on your own. Okay, so pause and try. Okay, now I assume you're back, and we're going to work this problem slowly but surely. Okay. So first of all, if we're talking about gallons per minute, what are our units? Let's label our axes. Let's label the axes. So y over x, y per x. So these are gallons and these are minutes. Okay. So if it's a constant rate, that means a constant slope. That means it's a straight line. So there's a lot of answers to this. So we're going to start at 0, 0, but you could draw a line like this. That would suffice. But you could also draw a line like this if you so chose. Now let me ask you a question. Which is faster? Which is a faster fill? Well, for those of you that said this one, it's A or B. And the answer is A is filling faster than B because its slope is greater. Happy cat for anyone who drew a straight line. And a happy cat for anyone who can answer that A is steeper than B, so it is filling more quickly. Now, let's move to our other example. So now we're going to fill a bathtub at ever-increasing rate. So here again, we have gallons, and here we have minutes. And so the key is if we're at ever-increasing rate, that means our slope is greater as we move to the right. As time goes by, we're going to get a steeper and steeper slope. So give that a try. I want you now to pause and try. Okay, I assume you're back now. So we're going to start here at 0, 0. And we're going to start with a slope that's not very big because we want to start it filling slowly. Now we're going to increase. So let's say we want to increase. So now we're going to make a steeper slope. Well, let's not do it that steep right here. Let's just make it a little bit steeper. Let's just make it a little steeper. And now let's make it really steep at the end. So what you can see is we have slow, medium, and fast. Gallons per minute. This is going to have the least. This is going gallons per minute. And this is going to have the most gallons per minute. Happy cat, happy cat, happy cat. Now, you could have also done something clever. Maybe some of you tried something along the lines of this. You said, well, all these lines don't have to be straight. What if I just did this? Made a curve and just made it steeper, 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 steeper. And this would also be okay. The line doesn't have to have these just 3 straight sections. It can have just a curved section that keeps getting greater. And I would give you a double happy cat for that and for that explanation. So bathtub filled at an ever increasing rate, a curved line, or just a couple straight lines. As long as the slope gets bigger and bigger. Filled at a constant rate, straight lines. All right. Now what I want you to do is, we have a car. Here we have a car. And in this car, we are, there's a story. So we're driving, and we're driving in the first, we start at 0, 0. We start at hour 0, we're nowhere. But we get up here to 20 miles in about, if this is hour 1, 2, 3, 4, 5, 6, right? In about half an hour, 0.5 hours, we're 20 miles down the road. But then we don't get very far. In the next hour, we don't get an hour and a half. We really only go about 5 miles. So here we have a story of a car. And here we have some other story. Here we have we're just not even going anywhere. And here we're starting to speed up. And here we make a lot of distance at the end. So what I want you to do is identify the rates in these various segments. And let me just make the points really clear. Find your average rate in each segment. Let's just pretend that this is here. And let's just pretend that this last one is here. So this is 4,65. This is 3,30. This one is 2.5, 25. This is 1.5, 25. And this is 0.5, 20. And so we're going to call this section 1, section 2, section 3, section 4, point 5. So we have 1, 2, 3, 4, 5 sections. So this is section, we're just going to call, well, actually, yeah, let's call this section 1. This is section 2. This is section 3. This is section 4. And this is section 5. And so what you're going to do is you're going to find the slopes in each section. So in section 1, what is my slope? In section 2, 3, 4, and 5. Okay, so now pause and try. And after you get the rates, then we can find we can write the story. Okay. So we started at 0, 0. So in here, we're finding the slope between here and here. What is our slope? Our average slope. So in section 1, it's 20 minus 0 over 0.5 minus 0, which is equal to 20 over 0.5, which is equal to 40, for those of you who use a calculator. And our units are what? Miles per hour. And I'm just going to write MPH. So 40 in here. Now we have to find it in here. And so our difference is 25 minus 20 over 1.5 minus 0.5. And so that's 5 over 1, which is equal to 5 miles per hour. And that's for, right, this is for half an hour. And here we do this for, this is 1 hour, right? This is 1 hour from 0.5 to 1.5. In section 3, it's 25 minus 25 over 2.5 minus 1.5. So that's equal to 0 over 1, which is 0 miles per hour for 1 hour. And that makes sense. Right? We're standing still. We're at 25 miles and we stay at 25 miles. So we're not going anywhere. We have a nice flat rate, a nice flat line. We've gone, so it's not increasing, it's not decreasing. We're going 0 miles per hour. We're standing still. Now we start up again and we go 30 minus 25 over 3 minus 2.5. So that's 5 over 0.5, which is equal to 10 miles per hour. And we do that for half an hour. And now the last section where we kind of can tell we're going faster, we're making a lot of distance in 1 hour. So that's 65 minus 30 over 4 minus 3. So now we go 35 miles per hour for 1 hour. Right, this is 35 over 1, so it's 35 miles per hour. Okay, well, there we have it. So here's what happened with our rates. Now we can write a story. So let's write the story. And you can think about it. If we go 40 miles an hour, we're going kind of fast. Let's just write this here. We kind of go fast, then we slow, then we stop, then we go slow, then we go fast, right? And you can see that. It's a steep curve. Shallow, stopping, shallow, and then steep again, which means fast, slow, stop, slow, fast. Hopefully this is making some sense to you. So the story is we drive to Grandma's. This is my story. We drive to Grandma's. We slow down for a stop. We stop for lunch. We start up slow, and then we drive fast till we get there. And that's our story. Drive to Grandma, slow down for a stop. Here we're having lunch, and here we start up again, and then we drive fast on the rest of the way to Grandma's house. Okay, whoops. That deserves a happy cat for the story, a happy cat for our math, happy cat for the graph. And let's move on. We have one more slide. And here we go. This is Larry and his gift card. There's a lot of words here, but don't worry about it. I think you're going to get the hang of it pretty quickly. Pencil. Okay, Larry has a gift card. It has $80. He's going to spend $1 on day 1, $2 on day 2, $3 on day 3, and so on for 10 days. So he's, $4 on day 4, 5 on day 5, etc. So I want you to make a T-chart here in blue of his remaining balance on his card. Then I want you to graph it on this graph here. I've started you off on the graph. Then I want you to know how his spending is not constant by looking at the graph. I want you to look at the graph and tell me. We know his spending is not constant because it's increasing, right? He starts to spend more and more each day. But I want you to look at the graph and tell me how you know it's not constant. And then I want you to tell me whether his spending is decreasing or increasing. I think I may have just told you, but let's not worry about it. Okay, so now I want you to pause and try. All right, now I assume you're back. So let's see. So here we're going to fill out the rest of the chart. Here he spends 1, then he spends 2, now he spends 3, so that's 74. Now he spends 4, so he's down to 70. 5, 65, minus 6, he's at 59. 7, he's down to 52. 8, he's down to 44. 9, he's down to 35, 10, he's at 25. Okay, so let's graph our points. 1 comma 79. We've already done that. Wait, let's do a happy cat. Happy cat for getting the chart. Now let's go to our orange and our balance. So 3 comma 74. 3 comma 74. 4 comma 70. 5 comma 65. 6 comma 59. 7 comma 52. 8 comma 44. 9 comma 35. And then 10 comma 25. All right, so you can see there's his spending curve. So let's answer these 2 questions and then get out of Dodge. How do you know his spending is not constant? By looking at the graph. Let's do a happy cat. Let's enjoy a happy cat for those who graphed it correctly. How do you know his spending is not constant? By looking at the graph. And the answer is because the line is not straight. The slope is not constant. So the slope is not constant. So the rate is not constant. Now, finally, is his spending increasing or decreasing? Well, is this line getting shallower or steeper? Well, this is shallow. This is steep. And this is steepest. So we get steeper and steeper. So his spending is increasing. And that's consistent, right? So I asked you to look at the graph to answer the question, but you can see that his spending is increasing day in and day out. This guy is a spendaholic, and he needs to start saving or he's going to run out of money in probably 2 or 3 days. Okay, that's it for this. That's it for this lesson. We are done. Over. We are going to move in next. Whoa, look at my hair. What happened? We're moving next lesson into 8M6, lesson 6, and we're going to start talking about graphs and plots, and then trying to build lines out of random points that don't create lines, that don't create natural curves, and making sense of this. And this is the way a lot of data occurs in the real world, and a lot of important decisions are made. And you should look forward to that because it's a fun lesson, and we kind of stick with this idea of forming lines out of points and curves out of points through the end of the year. So give yourselves a hand for hanging with it. 9 more lessons and the year is done.